Senior Enterprise Solutions Architect at AWS. I'm just coming over 21 months here at AWS. It's been an exciting ride. I've been in cloud space for about, I would say, 10 years now, and have been in technology space for about 18 years. Previous to this, I was a long-time Microsoft person. That's where I did most of my cloud as well. I support my enterprise customers based off New York, New Jersey region here. So that's about me. So without further ado, let's dive into the session. So the flow of the session will be very much similar to what Chris did earlier in the morning or afternoon, depending upon where you are. We'll be covering a little bit of what our current portfolio looks like in terms of analytics and database services, while I also talk about some of the new announcements that we made at reInvent and around that time frame. So that's what the agenda for today is. What I'll be covering today is some of the pieces on analytics side. If you look at the screen, it's like Lakehouse architecture, some of the analytics services like Amazon Emr Studio, Amazon Redshift updates, Amazon Glue updates. And then on the database side, we'll similarly cover the basics around purpose-built database services and the announcements that we made on Babelfish for Aurora PostgreSQL and Amazon Aurora Serverless v2. So dig in deeper into all of these areas. So before we start doing that, what we have seen is that data volumes are increasing at an unprecedented rate, exploding from terabytes to petabytes and sometimes exabytes of data as well. So traditional on-prem data analytics approaches can't handle these data volumes because they don't scale well enough and are too expensive. We hear from companies all the time that they're looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. Data is growing exponentially. It's coming from new sources, is increasingly diverse, and needs to be securely accessed and analyzed by any number of applications and people. So hearing about challenges, many companies are taking all their data from various silos and aggregating all of that data into one location. What many call it data lake, which you might have today or probably are planning to build in your organization to do analytics and ML directly on top of that data. At other times, these companies are storing other data in purpose-built data stores like data warehouses to get quick results for complex queries on structured data, or in a search service to quickly search and analyze log data to monitor the health of production systems. As we see more and more customers using both data lakes and these purpose-built data stores, they oftentimes need to also move data between these systems. For example, moving data from the data lake itself to purpose-built data stores, from those stores to the lake, and between those purpose-built data stores as well. Let's dig into each of these concepts, starting with inside out. So think of storing your data in your data lake and then moving a portion of that data to a purpose-built data store to do additional machine learning or analytics as the inside out approach. Your data lives in a central data lake repository, and for specific use cases, you move a portion of that data out to the analytics services for additional processing. For example, you want to collect probably web clickstream data from your applications directly into the data lake, and then move a portion of that data out to a data warehouse for your daily reporting and dashboard requirements. Let's now look into the outside-in approach. In these situations, these same companies are storing other data in purpose-built data stores, like a data warehouse, to get quick results for complex queries on structured data, or in a search service to quickly search and analyze log data to monitor the health of production systems. And while you have data in purpose-built data stores like a data warehouse or search service, you may need to move some of that data into your data lake to do additional analysis and machine learning on it. Think of this as the outside-in approach. Your data lives in purpose-built data stores that are optimized to give you the performance and scale you need, and you can move a portion of it in your data lake for additional processing when you want it. For example, you may want to move the query results for sales of products in a given region from your data warehouse into your data lake to train product recommendations algorithms using machine learning. Now, most of these architectures will really depend upon your existing IT environment, the applications you have built, and how your data is moving. But this is what we have seen traditionally as outside in or inside out approaches. So now let's look at the movement around the perimeter that is between the purpose-built stores. And that's what it looks like. In many situations, you may want to move data from one purpose-built store, like your relational databases, to another, like your data warehouse, which is a very common scenario in enterprise organizations, or between your non-relational database to a search service. This means being able to easily replicate and combine data from across these purpose-built data stores. For example, if your product catalog data is in your database and you want to move it to a search service to make it easy to search your product catalog. So let's put this all together and what it looks like. So this is how, if you put it all together from the perspective of data movement will look like. It's important to use the right tool for the right job. And it's equally important to ensure that data can easily get to wherever it's needed with the right controls to enable analysis and insights. As data in these data lakes and purpose-built stores continues to grow, it becomes harder to move all this data around because data has gravity. To enable themselves to get the most out of their data at any scale, customers are rapidly modernizing their data architectures. So let's look at what modernizing the data architecture achieves. First, building a modern data architecture that allows them to rapidly build a scalable data lake. Using a broad and deep collection of purpose-built data services that provide the performance required for use cases like interactive dashboards and log analytics. Enabling themselves easily move data between the data lake and purpose-built data services, setting up governance and compliance in a unified way to secure, monitor, and manage access to their data, choosing cloud services that give them low cost without compromising performance or scale. All these things, when combined, we call this modern cloud-based analytics architecture, the lakehouse architecture. It's not just about integrating your data lake or your data warehouse, but it's about connecting your lake, your warehouse, and all your other purpose-built services into a concurrent whole. Let's talk about what a lakehouse architecture looks like on AWS. So if I replace the components here that we saw on the previous slide, this is what a lakehouse architecture looks on AWS. We'll look deeper into these services in the following slides. Let's dive by discussing scalable data lakes, which is at the center of this architecture. Amazon S3 is the best place to build a data lake because it has unmatched durability, availability, and scalability. It has the best security, compliance, and audit capabilities, the fastest performance at the lowest cost, the most ways to bring in data, and the most partner integrations. It is built to store and retrieve any amount of data with unmatched availability and built from the ground up to deliver 11 nines of durability. Unique capabilities include storing customer data in independent data centers across 3 availability zones with a single AWS region and automatically replicating data between any region regardless of the storage class. You might be already using this service for your storage requirements or object storage requirements. But S3 is the most popular choice for data lakes as well. So in many cases, you also need purpose-built data services that we saw around the perimeter, which are optimized for specific use cases. While others will tell you that their product is the answer to everything, the truth is that one size doesn't fit all and leads to compromises in capabilities. By using the right purpose-built services with easy ways to integrate them through APIs and services that enable data movement, you get the best of both worlds. You can use tools that are best in class for a particular use case, so you don't have to compromise on performance, functionality, or scale. And you're able to get data where it needs to go to enable all your analytics use cases. Whatever you're looking to do with your data, AWS gives you the broadest and deepest portfolio of purpose-built analytical services. So let's look at that portfolio. We start with Athena. So Athena is an interactive query service that makes it easy to analyze data directly in S3 using standard SQL queries. It is serverless, so there is no infrastructure to manage. With Athena, there is no need for complex ETL to prepare your data for analysis. and most results are delivered within seconds. This makes it easy for anyone with SQL skills to quickly analyze large-scale datasets in S3. You pay only for the queries that you actually run, and you can easily see how much each query costs. Amazon EMR makes it easy to process petabyte scale data using the latest open source big data frameworks such as Spark, Hive, Presto, HBase, Flink, and Hoodie. If you want to quickly search and analyze large amounts of log data to monitor the health of your production systems and troubleshoot performance, you can use Amazon Elasticsearch service. If you want to do real-time processing and streaming data, you can use Amazon Kinesis. If you have complex queries against structured data and you want super fast query results, you want a data warehouse like Amazon Redshift. And we'll get into more details about the latest announcements on Redshift side quickly. These services are built to be best of the breed, which means you never have to compromise on performance, scale, or cost when using them. For example, Amazon Redshift is 3x faster and at least 50% less expensive than other cloud data warehouse. Spark on EMR runs 1.7x faster than standard Apache Spark 3.0, and you can run petabyte scale analysis at less than half of the cost of traditional on-prem solutions. So let's take a closer look at some of these, starting with Amazon EMR. So like Athena, EMR runs directly against the data stored in your S3 data lake. You don't need to move that data or transform your data. With EMR, you can easily create clusters, provision one, hundreds, or thousands of compute instances to process data at any scale. EMR automatically manages cluster sizes to scale up or down based on utilization, and you only pay for what you use. Because you're running against S3, you can have multiple clusters operating on the same data. EMR decouples compute and storage, giving you the ability to scale each independently. We launched the first version of EMR in 2009. That was over 10 years ago, and have been constantly innovating in areas such as performance to make sure EMR is the best place to run your Spark workloads, as well as workloads for other frameworks like Presto and Hive. With that, let's look at the new announcement that we made at reInvent. We announced Amazon EMR Studio in preview. Amazon EMR Studio delivers fully managed notebooks with SSO integration, which is single sign-on integration. So Amazon EMR Studio is an integrated development environment, or an IDE, that reduces the time for your data scientists and data engineers to build and deploy code. It is fully managed application with single sign-on, Jupyter notebooks, automated infrastructure provisioning, and job diagnosis. You and your team can log into Amazon EMR Studio directly through a secure URL to manage notebooks using corporate identities via AWS SSO. There is no need to log into AWS console. It is a completely new experience with multi-tenant studios where multiple users and groups can log into the same studio. Studio provides fully managed notebooks based on Jupyter Lab. If you are a data scientist, you will be very familiar with what Jupyter Labs is. It gives you the flexibility to create notebooks independent of clusters. You can attach and detach notebooks to and from clusters using a single click at any time. You can also provision EMR clusters using cluster templates pre-configured by your administrator, or create a new cluster from scratch. You can diagnose jobs on both active and terminated clusters using Spark UI, Thais UI, or Yarn timeline service. Studio allows you to do this easily by browsing through all of your clusters in one place and narrowing down cluster or job for investigation using filters. You can collaborate with your team and analyze data from your data lakes using PySpark, Spark SQL, SparkR, and Scala. Studio integrates with AWS CodeCommit, GitHub, and Bitbucket for easy collaboration. And you can import custom Python libraries like Pandas or NumPy and install custom kernels directly from notebooks. So you can see that it gives you a lot of flexibility and choice in terms of which language you use for your development. You can run notebooks as pipelines via Amazon Managed Workflows or Apache Airflow, self-manage Apache Airflow, or AWS Step Functions. You can also parameterize and chain notebooks that can be run as pipelines. So that's a look at some of what we have been up to in EMR. There were a couple of other announcements as well that we made, which I'm not covering today due to the interest, keeping in mind the interest of time. But when I send out the PDF, you will see those announcements in the document as well. So another area where we have seen rapid growth is in Amazon Redshift. So let's look at Amazon Redshift next. So with Amazon Redshift, you can take a lakehouse approach to analytics by adopting a data lake-based architecture. You can take advantage of real-time analytics or do ML/AI use cases without re-architecture because Redshift is fully integrated with your data lake. Sorry, team, I think I lost my audio there for a second, but I'm back. It's the only cloud data warehouse that lets you run queries at exabyte scale against your data lake, along with petabytes in your cluster, while also enabling querying of operational data stores such as Amazon Aurora. So Redshift also provides fast performance at any scale. Redshift delivers, as we have seen, up to 3x price performance than other cloud data warehouses. Concurrency scaling automatically deploys compute resources when needed to handle thousands of concurrent users and queries. And because all of the innovation the team has delivered, Redshift performs better than more data and users you throw at it, significantly outperforming other cloud data warehouses, especially as data volumes grow beyond 10 terabyte. Redshift provides a great value as you scale their data warehouse, and you can start small at 25 cents per hour and pay only for what you use with predictable monthly costs. It's at least 50% less expensive than all other cloud data warehouses, and pricing is clear and transparent. With options like reserved instances, you save up to 75% compared to on-demand prices when you commit to using Amazon Redshift for a 1 or 3 year term. And we are not done here. We are continuing to innovate to meet the needs of our customer in this space as well. So let's look at the innovation that we have done on Redshift side and the portfolio of different features. So by working backwards with our customers, we have identified 3 investment pillars. First is data lake and further integration with other AWS services and partners. Second is performance at any scale, from out-of-the-box query tuning to customers with strict SLAs that have multi-petabyte workloads, keeping it cost-effective and predictable to get the best value out of Redshift. So let's dive into a few of these capabilities in details. So we know that data is often used by different groups and for different purposes, both internally and externally. Today, some customers choose to keep all the data in the same Redshift data warehouse, also called a cluster, and others choose a multi-cluster deployment where they copy data from one cluster to another cluster. If all the data is in the same cluster, different groups and users within an organization are competing for the compute resources, and you can't easily charge different business groups for what they use. If you're copying data over to another cluster, it takes time and resources to manually unload data from one cluster and copy it to another. Creating copies can limit insight because you may not have the latest data and can make it harder to keep track of how it's being accessed and used. So customers asked us for an easy way to replicate data across multiple clusters so they can query and access same data without impacting performance, manage costs more easily, and set the right permissions, which is why we announced Amazon Redshift data sharing. Amazon Redshift data sharing, using that feature, you can share data across your organization with external parties to enable a broad array of new use cases. And what those new use cases are, you might ask. So let's dig into that. So with Amazon Redshift data sharing, customers have a simple and direct way to share live data across Redshift clusters. And in the future, in your data lakes as well, without making copies or complexity of moving data around. This makes it easy to instantly query the most up-to-date data for different use cases. For example, customers can use data sharing to run workloads in separate isolated compute clusters while accessing the data they need with minimal performance impact on individual clusters that share data. And this makes it possible to size and scale individual workloads for both price and performance requirements by only accessing the data needed. Data sharing enables secure and governed collaboration because customers can set permissions at a granular level, can easily track and manage access, and because customers can set permissions at a granular level for each independent Redshift cluster, multiple groups can access the data in a secure and governed way. If you look at this diagram, it's important how those things work and the kind of flexibility Amazon Redshift data sharing provides in terms of managing costs as well as performance. Using data across Redshift data warehouse simplifies many of our customers' use cases. And we have also heard that many customers want to expand the capabilities within their data warehouse as well. So that's why we announced Amazon Redshift ML. Data analysts and database developers want to leverage data in their Redshift data warehouse to train and apply machine learning models that can then be used to generate insights such as forecasting revenue, predicting customer churn, and detecting anomalies. Today, they move the data out of Redshift and then rely on ML experts to build and train the models on their behalf, or invest a lot of time learning new tools, technologies to do this themselves, which could be complex. Now, with the Amazon Redshift machine learning, Redshift users can create, train, and apply ML models with their data without moving the data and without learning new tools and technology. To create an ML model, customers use a simple SQL query to specify the data in Amazon Redshift they want to use as data inputs to train their model, and then they specify how they want that data analyzed. For example, you can create a model that predicts customer churn. A data analyst can query columns in one or more tables that is in Redshift that include the customer profile information and probably historical account activity as inputs, and define the output column as the customer churn prediction, indicating whether the customer is active or inactive. Once the customer runs the SQL command to create the model, Redshift ML securely exports the specified data from Amazon Redshift to Amazon S3 and calls Amazon SageMaker Autopilot to automatically prepare the data, selects the appropriate pre-built algorithm, and trains the model with provided data. So you can see that it makes it really easy for you to not only just train the models, but also to consume it. Once the model is trained, Redshift ML makes the ML model available as a SQL function to the Redshift users. Customers can use the SQL function to apply the machine learning model to their data inquiries or to reports and dashboards. For example, they can run the customer churn SQL function on new customer data in their warehouse on a regular basis to predict customers at risk of churn and feed this information to their sales and marketing dashboard so teams can take preemptive actions. So we know the role of database administrator is evolving as well. And new capabilities like this make it impossible to expand the scope of the role by bringing the power of both analytics and ML to the hands of our Redshift customer. To support this evaluation, we wanted to make it as easy as possible to manage and tune clusters. So achieving optimal data warehouse performance, if you are a DBA and work with Redshift, you know that is important to meet SLAs and control costs, but it can be hard to achieve because it can be time consuming, requires special skills, and sometimes gets neglected or can be done incorrectly. So we announced Amazon Redshift Performance Tuning Automated. So it delivers ML-based optimizations to get started easily and get fastest performance quickly. Let's look at what's available for customers now. So Redshift uses machine learning-based optimizations to simplify maintenance of the Redshift data warehouse and turbocharge performance. This makes it easier to get insights fast without spending valuable time managing your warehouse. Redshift does this by continuously monitoring user workloads and using sophisticated machine learning models to determine opportunities for improving data layout efficiencies. With the Redshift Advisor and auto-tuning, customers get the best tuning suggestions, some of which Redshift will intelligently handle on the customer's behalf. This makes the task of setting distribution keys. Just to clarify, this is something we announced generally available from an automatic table optimization perspective. And it makes the task of setting distribution keys, sort keys, fully automated. The advisor system continuously analyzes the workload of the cluster and table access patterns. Based on these access patterns, the advisor will generate recommendations to adjust the sort and distribution style of a table. And when a table is set with the property of auto, Redshift will automatically alter these tables' distribution style and sort key accordingly. Performance of queries ran on distribution auto table will be adaptively and automatically improved. We actually published a paper on our approach to analyzing query logs and using graph algorithms to determine an optimal recommendation. Because this is a continuous process, Redshift will keep your cluster in an optimized state even as data volumes grow and workloads evolve. Some other new capabilities that we announced were Auto Workload Manager and ML-based memory prediction to optimize throughput and maximize system resources, automatic table sort to maintain the sort order of the data in Redshift tables to continuously optimize query performance, and materialized view auto refresh and rewrite, which speeds up the query performance by orders of magnitude when using pre-computed results with materialized views. With automated performance tuning, you get the best of both worlds, sophisticated capabilities to optimize performance without having to become an expert in data warehousing optimization. And as we know in the cloud, better performance also means lower cost. So let's look into the next area, which is being able to provide seamless data movement. So AWS provides a lot of functionality and features and services to have seamless data movement, allowing you to easily move data between the data lake and purpose-built data services. So let's dive deeper into how we enable this for our customers, starting with AWS Glue. So AWS Glue is a serverless data integration service that makes it easy to prepare data for analytics, machine learning, and application development. AWS Glue provides all the capabilities needed for data integration, so you can gain insights and put your data to use in minutes instead of months. However, there is another class of user, and not just data engineers, that also need to frequently combine and move data between various data stores, and these are data developers. To replicate and combine data across multiple data stores, many developers today use ETL, which stands for extract, transform, load, including AWS Glue, which is one of the tools which does ETL, to build complex data integration pipelines that collect, combine, and keep data up to date. While customers love the scalability and flexibility of AWS Glue, this still requires developers to become proficient in the programming languages used by ETL tools, like Python or Spark, and can add months of development time. And when there's a change to a source database, such as a column being added or maybe removed from a table, developers have to rebuild those pipelines or rewrite their applications, which could be, very time consuming and may take a lot of effort. So being able to keep these data integrations working and up to date has been a missing link for a lot of people who have had multiple applications using multiple data across stores. So therefore, we announced a significant new capability in AWS Glue to help make it easier for developers to combine and replicate data. It's called AWS Glue Elastic Views. Glue Elastic Views lets you use SQL to quickly create a virtual table called a materialized view, which you're probably already familiar with if you're working with database systems, of the data that you want to combine from different data sources. Based on the materialized view definition, Elastic View copies data from each source database to a target database and then automatically keeps the data in the target database up to date. It continuously monitors the source database for any changes and updates the target database within seconds. If there's a change to the data model in one of the source database, it proactively alerts the developers so that they can update their view to adapt to this change. If they want to copy operational data from an operational database to their data lake to run analytics in near real time, it does that too. And it automatically scales its capacity as workloads go up and down. It takes away all the muck of trying to do this yourself and reduces the time it takes to do this from months to minutes. And we are excited to give this to our customers today. So you can actually get hands-on to a preview today. We also recently announced two new features for Glue ETL developers, data scientists, and data analysts. So let's look at them. The first is AWS Glue Studio. This was actually announced before reInvent, so you might have already heard about this. But it's a new visual interface for AWS Glue that makes it easy for ETL developers to author, run, and monitor AWS Glue ETL jobs. You can now use simple visual interfaces to compose those jobs that move and transfer data and run them on AWS Glue. You can then use AWS Glue Studio's job run dashboard to monitor ETL execution and ensure that your jobs are operating as needed. So over the last 20 years, the users for data analytics have grown as a result of a surge in the variety and volume of data that companies can collect. To prepare data for analytics or machine learning projects especially, data scientists and analysts have to either use spreadsheets to explore and experiment with data, or rely on data engineers and ETL developers to transform data into their required format before they can start doing their own modeling on top of that. This often delays the process for weeks or months, as customers can spend up to 80% of their time in data preparation tasks rather than actually analyzing the data. Glue Data Brew makes it easy for data scientists and data analysts to clean and normalize data using a visual interface. So that's another announcement that we made, and it's GA, reducing the time it takes to prepare data by up to 80%. With Glue Data Brew, you can visualize, clean, and normalize data directly by up to 80%. Oh, I'm sorry. Directly from your data lake, in fact, and data warehouse and databases. You can choose from over 250 built-in transformations to automate data cleaning and normalization tasks, and save these transformation steps so they are applied to new data as it comes in. You can evaluate the quality of your data by profiling it to understand data patterns and detect anomalies, all without writing a single line of code. As part of AWS Glue, Glue Data Brew is serverless, so you don't need to manage the infrastructure. You pay only for what you use with no upfront commitment. You can check out Glue Data Brew today on AWS website, and I'll paste these links in the PDF file as well, so that you can access them later on. Regardless of how and where you store your data, it's important to have unified governance capabilities as well to effectively secure the data and who accesses it. So we looked at the modern data warehouse lakehouse architecture. We looked at different storage options, the purpose-built store, the data lake, how the data can be moved around the perimeter. But again, governance is also really important in all these aspects. So this can be challenging when you are using a data lake and a collection of purpose-built data services to store and analyze your data, because managing security, access control, and audit trails on all of those systems is complex, time-consuming, and error-prone. Because it requires manually maintaining access control lists, audit policies across different systems, and large number of storage systems. But AWS Link Formation helps make that easier by providing a single place to enforce access controls for all services that access your data. It could be Redshift, EMR, Athena, and SageMaker. So we announced new features to Lake Formation, namely transactions, row-level security, and acceleration or performance acceleration as such. With these additional features, the Lake Formation data lake can be safely updated. It can be secured across all the people and applications which want to share the data and individual access is accelerated to provide a better experience. So let's dig deeper into these three capabilities. First, similar to traditional databases, ACID transactions make it easier for developers to build applications on your data lake. ERI, which is the ACID transactions for concurrent updates on AWS Lake Formation, introduces a new type of S3 data lake table called a governed table that supports transactions. Without transactions, developers write complex and error-prone logic to ensure applications are operating on the right data, or they end up stalling or delaying analysis until changes are properly installed. To use governed tables, you simply register your data files with Lake Formation. They remain in your S3 data lake in open formats, and you use the Lake Formation APIs to get ACID transactions. The second area that we defined was security and governance with granular low-level filtering, row-level filtering. So until now, you could only define security at column level, but now we also are announcing row-level security and governance. So with APIs, you can enforce row-level security, including filtering unauthorized rows. Without this, customers need to maintain multiple copies of their data lake tables. For example, in government, they would keep confidential, secret, and top secret versions. And in healthcare, they would probably keep different copies of patient records for each group of users, like probably nurses, doctors, and admins. So this is cumbersome because copies are expensive and customers need to run data pipeline to keep them up to date. With ED, customers can specify what to filter or obfuscate with row-level policies or for groups. ED Red APIs will automatically consult lake formation policies and apply those filters before returning the results. The third benefit is improved performance, which is the acceleration area. And ED's Red APIs will filter rows from tables in your S3 data lake, similar to S3 Select, as well as compute aggregation statistics. For example, image a table of page view data. Customers could retrieve page views from last Sunday or compute average page load latency directly from ED's read APIs. This speeds up the analytics queries in services like Athena because they can offload this heavy lifting to ED. ED Storage Optimizer also automatically compacts tables in S3 data lakes asynchronously in the background. Streaming loads from services like Kinesis are notorious for creating innumerable small files on S3. When analyzing these small files, services like Athena have more overhead processing file requests instead of processing the data itself. The ED Storage Optimizer can improve read performance by 7 to 8x in such cases. So by leveraging lake formation, you have a unique set of capabilities for unified access control and governance. Yep, so we already looked at this. So let's look at the announcements made in another area, which is business intelligence. So we have Amazon Quicksite, a scalable, embeddable, ML-powered BI service built for the cloud. And Quicksite is a serverless and seamless and scales from tens of users to tens of thousands of users without any infrastructure management or capacity planning. Often to ask ad hoc queries though, you include new data sets, the end business user needs to go back and forth and work with their BI team to update the model to account for new calculations or new data, which can take days or weeks of effort. So customers asked us for an easier way to do this. And so we announced Amazon Quicksite Q. So with Quicksite Q, you can ask any question on all of your data and get answer in seconds, as you can see on your screen. So Quicksite Q enables users to ask ad hoc questions about their business data in human readable language and get accurate answers in seconds. To ask questions, users simply enter questions in the Quicksite Q search bar. As users begin typing their question, Quicksite Q provides autocomplete suggestions with key phrases and business terms to accelerate the process. It also automatically performs spell check and acronyms and synonyms matching, so users don't have to worry about typos or remembering the exact business terms of the data. It uses deep learning and machine learning capabilities along with natural language processing to generate a data model that automatically understands the meanings and relationship of the business data. So your users no longer have to wait for weeks of data modeling by BI teams before they can start asking questions. So those were all the announcements on analytics side. Let's move on to the database side. We have a couple of things, but before we move into the database announcements, let's look at the portfolio of the services. So we already looked at the portfolio for business analytic, for purpose-built analytical services. This screen actually shows you the portfolio for purpose-built database services. A key to proper data foundation is letting developers do what they do best. Break complex applications that used to be developed as a single monolith application into smaller pieces and picking the right tool for the right job. So they need to first understand the use case, the access pattern, performance, scale requirements, and then pick the right building block for their architecture. Thus, AWS databases are purpose-built and optimized for your workloads. They are battle tested, have high availability, performance, scalability, and security built right in. We have, so let's walk through that. We have Amazon Aurora, for example, and Amazon RDS for your relational database requirements. If you want a high throughput, low latency key value store, we have DynamoDB. Or if you're doing work at the edge with IoT, where the data is coming in a time stream format, you may want to use series. You may want to use a database with called time stream database. So if you want to run managed MongoDB probably or manage Cassandra, you want to choose databases that allow you to have the right tool for the right job. So that's what our purpose-built portfolio of databases provides. So now let's look at a couple of announcements in this space. So first is introducing Babelfish for Aurora PostgreSQL. So Babelfish is a new translation layer for Amazon Aurora PostgreSQL that enables Aurora to understand queries from applications written for Microsoft SQL Server. With Babelfish, applications currently running on SQL Server can now run directly on Aurora Postgres with little to no code changes. Babelfish understands the SQL Server write protocol and T-SQL, Microsoft SQL Server's query language, so you don't have to switch database drivers or rewrite all of your application queries. For people who have done migrations from competing vendors for databases, they would know that it is really difficult to not just migrate the databases, but the applications more so. And that's where Babelfish comes in to make it really, really easier and faster and accelerate that migration. Once you're done with your application testing, you can shut down that SQL Server database and stop paying for the licenses you don't need. This can save months to years of time typically spent updating latency application code to work with a new database. But we did not stop there. We got more and more feedback from our customers on how desperately they wanted to move away from SQL Server and how excited they were about Babelfish. And a lot of them wanted to be able to also make their own modifications and extensions to the translation layer. So we decided to make Babelfish for PostgreSQL open source project. So with open source project, that makes the source code for this translation layer available to anyone who wants to customize it and add new features. All the work and planning will happen on GitHub so that you get complete transparency into what specific SQL Server functionality we are working on next. If you want to add your own modifications, you can do that as well. The project will use the permissive Apache 2.0 license. Customers can actually sign up for Babelfish for Aurora Postgres today. It's available in preview. The next announcement that we made in this space was with introduction of Aurora Serverless v2. So people who have been already working with Amazon Aurora, they might know that we already have an offering from Amazon Aurora Serverless. We call it now V1. But V2 provides more functionality and makes it for the enterprise ready. So Aurora Serverless V2 can scale database workloads from hundreds to hundreds of thousands of transactions in a fraction of a second. Instead of doubling capacity every time a database workload needs to scale, Aurora Serverless V2 adjusts capacity in fine-grained increments to provide just the right amount of database resources that the application needs. Customers only pay for the capacity they consume and can save up to 90% of their database cost when compared to the cost of provisioning capacity for peak load. Aurora Serverless V2 also provides the full breadth of Aurora capabilities, including multi-AZ support, global databases, read replicas, backtrack, and parallel query. This was the most demanded feature. Aurora Serverless is now ideal for much broader set of applications. So those were the two announcements on the database side. With that,
yeah. If you could start summarizing, because we want to keep things flowing. There's so much good information here, but we want to just be aware of time constraints and other speakers. So if you could look.
Perfect. This is my last slide, actually.
Oh, perfect.
Yeah, right on time. So So with that, I wanted to leave you with a picture of a lakehouse architecture in AWS. We have already walked through this, what it looks like. What are the different purpose-built storage options that you have for your databases or analytics services, whether it's, Redshift for warehouse, whether it is Amazon Aurora for your relational database needs. We also looked at the data movement scenarios and how AWS Glue makes it easier to move data between these purpose-built data stores to data lake, or from data lake to purpose-built data stores, or within the purpose-built data stores. So that's hope you were able to grasp some of our analytical tools and the approach that we have taken and the technologies that we have made available to the broader community with the new announcements as well. So with that, I want to thank you for your time today.